Thank you guys for coming out to this session I'm very excited to talk about. It's called The Rise of API-First Applications. As a quick introduction, my name is Travis Tidwell. I'm the CTO and co-founder of Mayo. We're one of the sponsors here, so some of you guys have come by and said hello. And very excited to offer that solution to developers. I'll talk a little bit about it at the very beginning of this session. You can find me on Twitter. I'm Software Gnome. Don't expect much from me. I don't tweet that much, but it'd be great if you came and followed me. I like to keep up to tune with what's going on the web, and that's one way I do it. Where you'll really see me on is github.com. I'm Travis T on GitHub, so I've got a number of open source libraries, primarily JavaScript, a lot of Node.js, but really everything I do in the marketplace I put on GitHub, including this presentation, including all source code. So you guys can get on there and find this presentation. If you guys want to fork it and modify it and use it on your own presentations, feel free. Before we do get started, I would like to just talk very quickly about Mayo. So we are a combined form and API platform for developers. So the idea is we're offering a very easy to use drag and drop form builder interface that allows you to build a form using tools that you're very familiar with. Each of the fields that you drag on there, you can create custom validations using JavaScript, and all of the validations execute on both the front and the back end at the same time. But in the process of building a form, we're essentially saying that you've defined an API schema. So over on the left-hand side, you have a form. On the right-hand side, you have the API. Where the rubber really meets the road is whenever you want to embed those forms into your custom application, which you can do using a very simple AngularJS directive. And that makes the form come alive in your single-page application. And it's a REST-driven API platform, very easy to use. We have a free offering, so if you want to come just try it out, just create an account, and we'd be happy to have you. So with that said, I'd like to move on. Another thing that I like to do is offer presentation materials. Sometimes this board can be really hard to read, so you can actually go online and view this on your own computer if you just want to have it right there in front of you. There are some movies in this video, or in this presentation, so I think if we all did that, it'd probably take the network down, which I don't think there's any surprise there. Maybe later tonight, if you want to revisit this presentation, feel free. The URL's right there. Also, you can find me on GitHub, Travis T. I have a repo called Presentations that I have, and this repo is up there as well. And I do a lot of YouTube videos, and in fact, this presentation I'll be posting on my own YouTube channel, as well as I have a lot of other tutorials on mean stack. I'm very into Node.js, server-side JavaScript, as well as front-end JavaScript. And then, of course, I have a website, travistidwell.com. So I think what I'd like to talk about in this presentation is that something is happening in the web. And I think all of you know this. I don't think that really comes as a surprise. But there's a lot of interesting paradigm shifts that have been happening recently within the web. And if you really want to dive deep into understanding what these paradigm shifts and what these trends are, it's almost enlightening to start off by going to trends.google.com, and you'll see a number of things that are occurring. On the very top, I know it's hard to read, so on the very top left graph you have Internet of Things diagram, which is people doing searches for Internet of Things. The top right is AngularJS, which all of you know what AngularJS is. In my opinion, AngularJS is an enabling technology that allows you to build apps differently, that allows you to interface with Internet of Things type of architectures. The bottom left is mean stack. The mean stack is a Node.js based stack application, which is skyrocketing as well, and then on the bottom right you have REST APIs. One thing that I find very interesting about these diagrams is they all correlate with each other. They all have a very similar point of inflection, and that's one thing I would like to talk about first, which is in mathematics you have this thing called an inflection point. And what happens with an inflection point is when a trend changes. The concavity of a diagram changes so that what was the trend, a catalyst occurs that makes that trend dramatically change. And these inflection points don't happen very often in the web. And in fact, there's really only been about 3 inflection points in the history of the web. And I feel like it's very important to kind of start off by talking about these inflection points. These are the points where something happened that changed the nature of the web. And it affected every developer out there. In fact, we've actually given, because we're all programmers, we've given these 3 inflection points version numbers. And so you have Web 1.0, Web 2.0, Web 3.0. I mean, that's just the way we do it. But really what we're describing in those major version numbers are these dynamic and radically changing events that have changed the nature of the web. And in order to really understand where we are today, it's very important for us to kind of take a trip back through memory lane and start from the beginning and just talk about Web 1.0, go into Web 2.0. I know a lot of this you already know, but there's some things that I want you to take away from this discussion that is very profound in how developers are having to deal with Web 3.0, which in my opinion is dramatically different. So let's take a look at Web 1.0. And a lot of you guys know that this is the static web. Some of you were around for around long enough to remember this, but essentially what it was is a one-to-one connection between the browser and a file that was on a server. The file was an HTML file. It was just index.html. The browser would request to the server. The server would actually see the location that the user wanted the file. It would quite literally go and grab a file from the file system and hand it to the user. And that was the interface to the website. That was the static web. One takeaway that I want you guys to take away from that is the way that the server is actually handing the interface to the user. It's extremely important that you guys take that away because that is something that evolves over time. So the user's requesting the interface. So what ended up happening is people realized, okay, now that we got this request coming into the server, we can do some really cool stuff with this. We can write some server-side logic that dynamically builds that page and make it dynamic. And through that really came this introduction of Web 2.0, which was the dynamic web. And what that was is there was not only programming languages, which PHP became really big from this movement, but also databases. You were able to finally connect to databases and serve dynamic content based on dynamically generated templates. And this was a big deal. And people realized that not only could you create a dynamic website out of this, but you can also offer this to the community so that people can contribute content to the web through databases. So people could actually be filling out database entries that would then contribute to the web. And through that, within Web 2.0, came this rise of the CMS. How many in here have a history of some form of CMS? Drupal, WordPress, Joomla? A lot of you. So a lot of you already know this. And I'm not really trying to teach you anything new about this, but what I would like to at least as a takeaway, is recognize that the nature of the request really didn't change. From the user's perspective, they were requesting to the server, and the server, even in the CMS world, was sending the interface to the user every time. So the user was requesting the interface. The user would then click on a button on that website. What would it do? That would send a request to the server, and the server would hand it a new interface saying, okay, here's your new interface for you to interact with. Every single time, the user requested the interface from the server, even within a CMS. And from this moment in time, the world was great. You know, things were really rolling. You know, all the developers were happy. Not to say that developers aren't happy now, but it was a good time because you were able to build a website. You were able to, your customers were happy. All they wanted was a website. It was easy with the CMS. And CMSs became big from that. And then this happened. So during the 2.0 period, we actually ended up having mobile devices were introduced, and the iPhone was really the game changer in the market that all of you remembered. And all of these website owners, these business owners, went out and got their first iPhone, and they're like, "Yeah, this thing is awesome." What was the first thing that they did? If they owned a website, they're like, "Oh, I'm gonna go check out my website on this thing," and they were like, "Oh man, this thing sucks. My website looks horrible on this thing." And the reason is because we've suddenly introduced a new interface that no developers were used to. And so we had this period of scrambling, and it really was. It was a massive period where developers were scrambling to figure out, okay, we got to figure out something here to make it so that websites look good on these alternate interfaces. And we came up with a solution in Web 2.0. And in fact, all of you could almost complete my sentence, which was, if you're going to build a website, build it what? Mobile first. It was like this big tagline. We're going to build this thing mobile first. And so let's talk a little bit about what that meant. So mobile first was a movement in development that basically said, we're going to still deliver websites to the customers, but when we deliver them, they're going to be responsive. They're going to alter their interface and change based on the device that's displaying them. And the world was great. Okay? World was wonderful again. We finally felt good about ourselves. You know, our bosses were not barking down our throats because this website didn't look good on a mobile device. We felt good. But let's still talk about what mobile first was, because this is a very important takeaway. Even in mobile first, the server was still providing the client the interface. You were just doing it responsively. So as the user was interacting with this mobile website and clicking on a link and that was going to the server was still sending the user the new page. It was just that the new page looked good. It was responsive. The world was good at that time, right? Everyone was happening, everyone was happy. Bosses were happy until this happened. So suddenly, we now have interfaces, but now we have devices. We have this rise of these ancillary devices that still needed content from these servers, but guess what? They don't really have an interface. Some of these things are machines. Some of them are Fitbits that are human-driven, but it's not. The device is what's actually submitting data. It's the one that needs data, and it really doesn't have an interface. In fact, if there is an interface, it's embedded in the device, like the iWatch. So now we had a really big problem on our hands, and this is where Web 3.0 really comes into play, because we're now talking about a massive paradigm shift in the way we have to build applications. And I lovingly like to call this the rise of the machines, because that's really what happened here. And it's not to frighten you. I mean, if they do take over, all we have to do is install the IE6 runtime in there, and we're good, right? That's how we would solve the rise of the machines, in my opinion. So now we have a new paradigm shift, a new thing of the web that's really kind of altering the way we do things, because guess what? When you're building an application, you are no longer building that application to cater to a human. You're building an app to cater to humans and machines alike. And so now we're kind of faced with this, okay, what do we do? How do we build apps differently? And so there's been a bunch of developer mandates that have come out of Web 3.0. And these developer mandates are really rocking the world. And I think one of the most important things that I want to talk about, and I hope you guys agree with me on this, is that mobile first is no longer good enough. In fact, when you go to a session and they talk about mobile first, in my opinion, it's very, very outdated. Because mobile first is all about the server still sending the interface to the client, and that's just responsive. And so people start building apps not the way that they should anymore. So we need a new term. We need a new mandate. We need a new push on how do we build apps differently. And that's really where the term, the title of this presentation came from, which is the rise of API first applications. Because what I'd like to talk about is, instead of talking about mobile first, let's start talking about API first. And building apps that are ready for an API before we even say mobile first. So API first development is really what it's all about. So what I'd like to do is just talk a little bit about what it means for an application to be API first. The first and foremost is that you need to build your REST API platform first. Focus on the REST API. Make it a very robust platform that can not only serve a human interaction web application, but it could also serve machines if they wanted access to the data as well. The next point is, in my opinion, the most important one. Well, okay, this is very important, but it's not. I actually added this bullet here because another really big push is that the REST platform must be stateless. And I'm going to go into what that actually means later in this presentation, what a stateless REST API and how that works. This next bullet, I hope, in my opinion, is the most important one, which is your first app should be an API test that sits on top of that REST API. And you can really build a very robust testing platform around the REST API and get a very good understanding as to how performant and how well your API is going to work for the multitude of devices out there. And you don't need, so if you're building your REST API, in fact, it doesn't matter to me if you build it in PHP or if you build it in Ruby. You can build an API in any language. But one thing to take note of, once it becomes a REST API, it becomes a black box that can be tested by anything. So you could actually write your tests, and my personal favorite is Mocha. You could write Mocha tests to test an API platform that was written in PHP, and it works great. And so that's one thing that I encourage everyone to do, is to write tests around your API. And now, once you finally have a test around your REST API platform, then you design an app, a standalone application that sits on top of it. And I feel like using this method is the future. And so I know a lot of you are probably asking, okay, so why API first? Why should I do this? And I feel like the answer to that is because API first forces us to develop our websites like web applications. And I want us to start using those terms differently. There's a lot of people out there who say, yeah, I build web apps, when they really build websites. A web app is different. It's completely different. It's completely isolated from the backend API platform. It's a standalone application. And you are never requesting the server for an interface. That's like the golden rule that you just don't do that in API first development. The server should never hand you an interface. It should hand you an API. And so web applications is how you would build something to where the nature of your app works that way. And a website is, even if it's responsive, it's a website. So let's take a look about what does a API first application look like. And I think whenever you really break things apart, what you're going to realize is that you end up with a very standalone application in the front end. And the front end kind of becomes the champion here, because these web apps can really kind of exist on their own. And as long as they're connecting to the server via REST API, everything is happy. So I picked AngularJS. There's a lot of amazing frameworks out there that you can use, but just for this diagram, I said, hey, Angular is a really good front-end application that really caters to API first development. But another really important thing here is whenever I say don't ever request the interface from the server, these frameworks, especially the SPA frameworks, single page application frameworks like Angular, are really good about you having local templates. In fact, they don't even have to be local templates. I mean, they could actually request a partial, and that partial is loaded in real time as the person's using the app. And then the partial template has tokens sprinkled throughout in which the data is then put into those templates. When you experience it for the first time, it really is an aha moment. You're saying, okay, this is how you build an app. It really, really changes the way how you think about applications. And a lot of people, I want to kind of just get rid of the notion that you cannot make a single page application look like a website. You can. In fact, if you go to Form.io and log into our portal and actually use it, the entire thing is a single page application. And you would never know it. Because it feels like a website, but the whole thing is sitting on a CDN, actually. We are hosting our entire web application on a CDN. And you can only do that if you use this total separation between the app and the back-end REST API. Another thing that becomes very important is local storage. Local storage becomes like your temporary local database where you can store things and use it within the application to do a lot of things on the front end. In fact, once you start building these API first applications, you will find yourself doing a lot in the front end because it's more efficient. You want to get as much off the servers as possible. In the front end, you have For every client that's connecting to your server, each one of those have their own computer. It's like it's mass distributed computing here at your fingertips. Take advantage of that. Make the apps do a lot of computational stuff as long as it doesn't bog down their interface, it's totally reasonable. And if you actually break up what a single page application looks like, it's going to look a little bit like this, where now you're loading a template, and the template is sending these requests to populate JSON content, and sending, hey, I need data to populate up here, I need data to populate in here, and you've got a multitude of REST APIs that are getting called to populate this single page. And I know some of you guys are already in your mind thinking of the most argued point on why SPAs are bad from this one diagram. So a lot of you are thinking, how in the world is the left better than the right? Now, instead of having a single request to my server send my entire application, how is that better than having an application that for every page load is completely bombarding my server with requests? I'd like to talk about that because I think a lot of you who think of that, have that notion, are really thinking in terms of Web 2.0 and how the server is actually handling a request. So let's actually take a look at what the server response looks like for a Web 2.0 type of application. And then I'd like to move on to how you would actually structure a Web 3.0 infrastructure to handle what's on the left actually even more performant than what's on the right. So I come from Drupal and have a long history in Drupal CMS where I built Drupal. And so some of this may actually look familiar to you because this is actually what a Web 2.0 request loop looks like. So on the very far left, you have the client is actually sending a request to the server. For any of you guys who have used PHP, you will know that once a request hits a server, it's actually spinning up a separate thread, and that separate thread is actually bootstrapping your entire application on the back end before it actually even executes the request. That's called the bootstrap process. Drupal is really bad about this. A lot of you don't even know that when you're using Drupal, every request that you hit the server, Drupal is like reinitializing itself over and over and over again. And that takes, on average, for Drupal, it takes about 200 milliseconds just to do that. So now you got 200 milliseconds of your request is taken up in a bootstrap process, and then at that point, your application starts just hammering the database. It's hammering the database to, okay, I need to load my menu system, I need to load my block system, okay, they want this little view over here that has a list of popular content, so now I need to hit a database to get that query. And what you end up with is just this pinging up and down, up and down, up and down, up and down from the server to the database until it's finally got all of the content that it needs. Then it sends that response back to the client, and that typically, if you're in Drupal, you're lucky to get that under 1 second. So 1 second later, the customer gets a response back, and to be honest with you, 1 second is considered good in Drupal. If you get a page back in 1 second, you're like, man, that's fast. And you guys are laughing because you probably have experienced that. Some pages are even worse. So let's compare that to what Web 3.0 looks like. And I think once you actually realize how, if the architecture changes, you can serve a massive amount of requests because now we're moving to what is called a microarchitecture environment where you no longer have this massive server to serve requests. You have a bunch of little ones. And guess what? With something like Node.js serves requests already bootstrapped. That is one of the most underplayed features of Node.js that people don't really talk about. But once you experience it, you're like, oh my gosh, this is amazing. The Node process is just bootstrapped and ready to take requests. And it does it asynchronously. And now you can have a multitude of these things lined up with each other, and they can be tiny. And each one of these servers is responsible for the REST API. And once the REST API hits, it makes maybe a few database calls and then gets right back to the client. But one point to make here is that all of these requests are done in parallel from the app. And all of them are responded in parallel because of the way that Node.js or some of the event-driven server architectures work. You end up with a more responsive, more performant website, web application. Even though you're sending multiple requests to the server, you notice that things get faster. Another thing that I want to take note of is I'm going to go back to this diagram. I came from a world where this 1 second was actually like 3 seconds per customer, and we could just have one guy surfing the web, one person, and it was still 3.5 seconds, because really the only way to squeeze this into a tighter space was to do what? Make this guy just enormous. At that point, you're buying CPU, and massive CPU and massive RAM, because you got to squeeze that request into as little as possible so that that one visitor you have is happy. It is almost laughable because everyone's doing that. Everyone's like, how do we make this site faster? Well, obviously you can make some performance improvements here, but what a lot of companies do is they scale. They scale up their server and make it enormous. In my opinion, a better approach is to buy just like Arduinos, a million Arduinos. I'm being totally serious, because what you're going to end up finding is, you could get these things lined up in parallel, and you would actually have happier visitors, because one Arduino is hitting a database a couple of times and then sending a response back is going to come a lot faster than 1.5 seconds of trying to squeeze this massive server. But no, I love Node for this reason, because Node is all about sitting on these microservers. And put that in your mind. Instead of having one massive server, have a bunch of microservers. Go to Amazon, buy the cheapest servers you can find, but have 5 of them. And you will find out that if you architect your system this way, you're going to pay less money, and you're going to have a way more performant system than you ever did with PHP with a massive server. Another thing that is very, very important is that your APIs are stateless. And a lot of people have probably heard that, and they misinterpret it. Because a lot of people, when they hear stateless, they think, okay, now my system can no longer maintain states. That's not what it means. A stateless API just means that the API is not responsible for the state. You absolutely can have states, but you don't do it within the server. You don't have a session table. You don't, whenever a request comes into the server, you're not taking the session ID and then loading that session in the database, because that causes a scaling problem, because now you have 5 servers trying to synchronize, okay, who has this guy's session? And a lot of you, if you guys deal with load balancers, you'll finally start to realize, okay, once I have a session, I'm going to redirect that session to this server at all times, because if he sends another request that goes to another server, they're not going to know who that is. They're not going to get the updates. How many of you have that problem? Hands immediately fly in the air. The way you deal with that problem is actually very elegant. And there's a new technology that deals with it called JWT tokens. So using tokens instead of sessions is really the way to go, because what you end up with is a digitally signed, that's very important, a digitally signed JSON object that you hand to the client. And they are responsible for their own server. And it's secure because it's digitally signed. They can't muck with it. They can read it, they can see it, it's theirs, but they can't change it and hand it back to the server, or the server it'll fail validation. So what happens with that is, now, let's say every single request has its own session, has its own user object. For example, a lot of people take a session ID and they load in the database, what's the first and last name of the user? It's a good example. Now you actually send that information in the token. You say, okay, this is your name, because once you signed in, we actually created the token. We had to load your user object anyway to sign you in. We're just going to take that object and create a digitally signed object and hand it to you, and that's you. You can't change it because we'll know. And that's how JWT tokens work. So now something like this can happen, where one single page request can send 50 different requests, and they go to as many servers as it wants, and every single one of them know who it is, because the actual client is the one that handed his identity to each server through a JWT token. It's remarkably elegant. And you can store states in a JWT token. So as a person is using the app and their state changes, you can hand that information and digitally encrypt it inside of their token, and the world is wonderful, trust me. And so that's how stateless APIs should work. And the key there is using JWT tokens. So I'd like to talk a little bit about front-end architectures because we've been talking a lot about back-end architectures and how do you set up a back-end architecture for API first applications. Just as important is the front end. In fact, no more is the front end going to be a third-class citizen. It is now a first-class citizen. Legitimate developers have to essentially build this amazing app that is standalone. I'm very proud to call myself a front-end dev. And frameworks are your friend. Please use a framework. Do not invent one on your own. Although I'm sure at one point one of these guys was like, oh, I don't like that framework. I want to make my own. I'm going to call it Ember. And so there's like an XKCD comic about that I love. But these right here are really good, a lot to pick from. Okay, so you have AngularJS, React. They're all really good. Ember is really fantastic. The one on the bottom left is Backbone. That's been around a little bit longer, so I think they're coming out with some newer versions to kind of catch up with some of the others. And Ionic is really good. It's interesting. It's actually based on Angular, but it's built specifically for mobile apps. So if you're building like Cordova mobile apps and you want it to just look amazing, Ionic's a really good choice. Another thing that is very important and very popular right now is this concept of a single-page application. So single-page applications, they're a little bit interesting. Whenever you first experience a single-page application, it's a little bit jarring because you don't actually realize. It's really kind of hard to break the notion that when someone clicks on a link, it no longer sends that request to the server. And it really takes a long time to kind of break yourself of that. But single-page applications, when you click on links, it doesn't send a request to the server. It actually changes the state of the app. So let's say we have this red section here. That would be like the home section. And it wants to load content into the home section. It has a template that you see right here, which is a regular template, but it uses tokens. So these tokens, like the title, would be inside that token. And the tokens are denoted by these squiggly brackets. And then a REST API is sent out to the server. The server sends only a JSON response that needs to populate that one section. So you may have, as I said, 5 different requests from 5 different sections occurring at the same time, but that's okay, as long as you're not pointing at Drupal. You can do it with Drupal. I don't want to be critical because Drupal's awesome. For certain things, right? Okay, I had to throw that in there. Drupal 8. Let's talk about that. Drupal 8, it's awesome. But Drupal 8 is still making the mistake of sending the interface to the client. Oh, yeah. Yeah, it still has that problem where when you install Drupal and you get your website up and going, Drupal is handing you an interface. In fact, what it actually does, it decides to hand you JSON based on an accepts header that you hand it. So if you say, I accept JSON, it'll send you the JSON representation. And Drupal is also doing something, another interesting thing that I think you guys might be interested in talking about. It talks about, so this, I'm going to go back and slide. You got me going. So this right here, this diagram where it's like a bunch of API calls are getting made. Drupal doesn't, they don't like this. And because, for good reason why they don't like this, because Drupal has a problem on the back end where it does not do well with this. So if you're going to use Drupal, which you can, don't do this. You will be sorry. What you do instead is you have what's called a Bigpipe request. And the Bigpipe request works the way that every single one of these sections has an ID associated with it. And when you send that single REST API request to the server, it goes in and it basically populates a JSON response with all of the content and hands it back. It's still RESTful, it's still a JSON object, and then the template compiles it out the way it should be. I personally don't like that, but if you want to use Drupal, that is a very valid solution.
So is there a CMS that does it right?
Does anybody know? Here's what's amazing to me. Even Node.js frameworks get it wrong. I loved Sales.js. And Sales.js is an amazing Node.js framework, but it's like they're stuck in the CMS world. You're still compiling the template on the server. Even with modern CMSs, you're doing that. Even modern frameworks, you're doing that. That's why I feel like it's important as an industry, as developers, that we really kind of break this notion that the server is responsible for the interface. The app is responsible for the interface. And so I think right now, I don't really think there's much to pick from other than REST APIs. You can pick a good REST platform and use Angular and build your app in Angular. You'll be very happy if you did that.
There's a good opportunity.
So what?
Maybe there's a good opportunity.
A good opportunity. I formed a company which is based on that opportunity, and I'll talk about that here in a little bit. So the opportunity is what we're doing at Mayo, and I will talk a little bit about what we're doing. So going back to single page applications, let's say you click on the about link up there at the top. Again, this is not sending a request to the server. This is actually telling the state of the app to change. And the app says, okay, now we're in the about state. And so if you're dealing with Angular, you're probably used to the state machine where you set up what looks like URLs, routers, but really all it is it's a state machine. And it says, okay, whenever it's this state, I want to load this template, and then that calls a controller, and the controller sends a REST API to the server to get the response back. So it's a really fascinating technology. Single page apps, in my opinion, it is the future. Another thing that this opens up is the idea of a multi-service application. No longer is an application bound to the server, and I love this about single page apps because a lot of people who have been building websites using the old CMSs, they're probably very used to, okay, I need maps, so what do? I enable the maps module. That's what I do. We're so used to enabling modules that are back-end modules to expose a front-end capability. And Drupal's really bad about this. In fact, I did it myself. I wrote a media module for Drupal, and it was a media player. And it was a back-end module that you would install. And in my opinion, now that I know what I know, Drupal should just be holding the URL to the video. And that's it. How you display the video is up to the app. And when you do that, when you form that separation, it is very much a liberating experience, but it also liberates the application to bring in certain things without even hitting that server up there. So if you want maps, the application can talk directly to Google Maps. If you want Twitter, the application can talk directly to Twitter. If you want Discuss, it can do that as well. Discuss is a great example because Discuss uses comments that if you want comments within your application, you just embed this widget and it just works, and you don't have to build a comment system in your backend. But that's a great illustration of how that this microservice architecture is really redefining how we build applications, starting with the application itself, where it can talk to a number of things, including if you want a form for Mayo. So this type of architecture is really helping us go from this one-to-one connection. So we all have this, I have a website and it only talks to one server. We need to really start breaking ourselves of that because you're really going to open up the door of amazing possibilities when you realize that your application is standalone and it can talk to however many services that it wants. And it takes it from something like that to look like something like this, and they're calling this the microservice architecture movement. So if you guys have heard of microservices, that's what this is about. This is about each service serves a purpose, does it really well, and the applications can decide to pull it in if they want to, and now you have this highly distributed way of building applications where they can consume whatever APIs that they want. And this is all driven by APIs. So let's talk a little bit about where this is going. I think once how am I doing on time? I'm good. You guys are going to leave anyway because we're going to do this drawing away, right? Except that guy, he's like, what? Where do I sign up for that? All right. So I would like to talk just very briefly about where this is going. And I think whenever you fully separate apps from the API platform, something almost magical happens. And it really brings out a concept that you have this standalone application, and it is now connected via API to a very configurable and deployable API platform. So now you have these two things that are completely separate. And I bring up configurable because APIs can be configured to behave a certain way. And that's kind of what we do at Mayo. You're really configuring an API to behave a certain way. Once you do that, you really bring in this new concept that we're starting to explore called a community of application sharing. So here's the idea. On GitHub right now, we share code. And we may share some Jekyll websites. We may share some front-end sites. What if, because you have a piece of front-end code that is a standalone application, and all you have to do is configure an API for it, couldn't it be said that we can now share apps, full working applications that you can fork, you can modify, you can share with your friends, and you can extend? And every single time you share it with somebody and they spin it up, they get their own configured database automatically for them. Let me explain how this works. So if any of you guys registered for this guy, you probably filled out an application. And that application is available on GitHub. So here's how this works. So if any of you guys work for a company and you guys want to go to a conference and you guys kind of want to have the same app, wouldn't it be great if I could just fork that app and bootstrap my own thing and in 1 second have my own version of it, fully working? And so on GitHub, you'll notice we're under Mayo. We're a very open source company. There's a lot of open source things here. We actually committed this prize drawing application as a Mayo app. There's one important difference with this app, is that inside of it, inside the source, you'll see this project.json file. This file is a JSON representation of the REST API that is necessary to support the app. So that when I clone this, not only do I have an app, but I also have the schema for the REST API that needs to support it. And then what's really cool is that we also created a command line interface that you can download to bootstrap working applications. So let me just show you what this looks like whenever you run this thing. So once you go and create an account on Mayo, you go find an application that you like. You first start off by installing our command line interface. So this doesn't take much time to install. Once you actually have this thing installed, you now have the ability to say, I like this app on GitHub. I'm going to bootstrap by typing Mayo bootstrap and then the app URL on GitHub. And keep in mind, that could be your forked URL. I sign into my GitHub account. Because this app has that JSON file, it knows how to build it on Mayo. It downloads the project and it bootstraps a working application with a complete sandboxed app within Mayo. So now I go to Mayo, I have the project that supports my application, including admin logins, user logins, as well as the form itself that you guys filled out to enter this drawing. And I also have a working application on my local machine. And if you want to change it, for example, if you're not giving away a BBA droid, that's in the app. You fork it, you change it. You can even modify the form that is shown based on Mayo. You have full access to the form, so I can drag and drop the form, make that form whatever I want, and you now have, within about 10 seconds, a fully bootstrapped working application.
Is the server side for that, though, hosted on Mayo?
The server side is hosted on Mayo, but guess what? If you go to Mayo/Mayo, you will see that there is an API open source platform that you can spin locally on your machine, and it's one configuration deployed to your local machine. And it's BSD licensed. So I feel that this is going to create this app sharing for the ability to, hey, for one developer to say, hey, I got this to-do application that I built. I think it's really cool. Hey guys, bootstrap it, or fork it and clone it and bootstrap it, and then they'll fork and bootstrap it, and it'll basically be a working application. So I really feel like this is kind of what you get out of that total separation of an API-first application. You could not do this. In fact, they've tried to do this for many years with Drupal. They really have. They tried to create distributions. They try to make it easy for people to modify it, make it themselves, and then share it. The problem is once you anchor the front end to the back end, it causes a problem. You have to have these standalone apps that are completely separated via REST APIs. So with that said, all of you filled this thing out. You entered. We wished you luck. I think it's about time that we pick a winner. What do you guys say? So here is the application that you guys filled out. This is a working application, as well as allowing an admin interface. So with Mayo, you can build an admin login, you can build user accounts. So I'm actually going to log into my admin account here. And all I have to do is click to reveal. Now, if any of you guys are weary about, okay, what's behind that? Go check out that repo. The source code is available. And I hope all of you are comforted to know that it's math random. Does anybody have concerns about that? Oh man, I was actually expecting everyone's hands to raise. So basically here, before I click on this, because really whatever shows up here is going to be the winner of the BBA. This is full API driven, and I'm actually we have a streaming export that is associated with the form, so you can actually stream the export JSON object. So that's what this does. This will stream the export, and out of the list of everyone, it will pick a winner. Do we need a drum roll or something? I mean, all right, so here it goes. You guys ready? 3, 2, 1. Is this person in the room? All right, well, you don't have to be here to win. So we're going to send this guy an email. He has 2 hours to pick this up. If he doesn't, we will do another drawing, and we'll send that person an email, but let's assume that this guy's going to pick up his BBA. That's it from me, guys. I really appreciate you guys coming out to this, and thanks and have a good one.